Hey there, and welcome. Today, we're going to dive into the two huge movements that basically run our lives here on Earth: rotation and revolution. It's this amazing cosmic dance that gives us our days, our years, and even our seasons. So let's get into it. Have you ever really stopped to think about it? Why does the sun faithfully rise every morning and set every evening? Why do we have blazing summers and chilly winters? It all boils down to two simple but incredibly powerful motions. And trust me, by the end of this, you'll see our planet like a beautifully designed engine. So here's what we've got lined up. We'll kick things off with our planet's daily spin, then check out all the wild effects it has. After that, we're zooming out to look at our year-long journey through space. We'll bust a few myths about the real reason for the seasons, look at the beautiful precision of it all, and finally, we'll tackle that mind-bending question. With all this motion, why don't we feel a thing? Okay, first up, let's talk about the motion that gives us our daily rhythm. This is Earth's constant, steady spin, something that's happening right now, this very second. So what is rotation? Well, think of the Earth as a giant spinning top. That's really all it is. It's spinning on its own axis. Now, technically, it takes about 23 hours and 56 minutes to do one full spin, but we just round that up to a nice clean 24 hours. And it spins from west to east, which is exactly why the sun appears to rise in the east and set in the west. Now, this axis we're talking about, it's not some physical pole sticking through the planet. It's an imaginary line that goes from the North Pole straight through to the South Pole. But here's the absolute most important part. It's not perfectly straight up and down. It's tilted. And I want you to burn this number into your brain, 23.5 degrees. This little tilt is the secret key to so much of what happens on our planet. So you might be thinking, okay, it spins, we get day and night, big deal. But oh, there's so much more to it. This daily spin has some really surprising and widespread effects. Yeah, of course, you've got the obvious ones, day and night, sunrise, sunset, but then you get into some really cool stuff. That spin creates something called the Coriolis effect. It's this invisible force that actually steers winds and ocean currents, shaping our entire planet's weather. It's why stars seem to wheel across the night sky. The spin even creates a force that causes the Earth to bulge out a tiny bit at the equator, so it's not a perfect sphere. And of course, it's the whole reason we have time zones. And this image just shows the most direct effect perfectly, right? As our world turns, one half gets bathed in sunlight, that's daytime. The other half is turned away, sitting in shadow. That's nighttime. It's this beautiful, simple, nonstop cycle, all thanks to that 24-hour spin. Okay, so we've got the daily spin locked down. Now let's zoom out, way out, and look at the bigger picture, Earth's epic, year-long road trip around the sun. This is called revolution. So while the Earth is doing its daily spin, it's also moving along this massive, fixed path, its orbit around the sun. And it's not a perfect circle, by the way. It's a slightly stretched out circle, more like an oval that we call an ellipse. And this whole trip, it takes about 365 and a quarter days. Now that little quarter of a day is super important. It's why every 4 years, we add an extra day, February 29th, to our calendar. That's a leap year. It's how we keep our calendar perfectly synced up with our planet's journey. And one of these full trips is what we call a year. All right, it's time to tackle one of the biggest myths in science. A lot of people think that it's summer when the Earth is closer to the sun and winter when it's farther away. It makes logical sense, right? But it's totally wrong. The real reason is way cooler, and it all comes back to that special number we talked about earlier. And here it is again, 23.5 degrees. This is it. This is the whole shebang. The entire reason we have summer, fall, winter, and spring is packed into this one little number. It's not about our distance from the sun, it's all about the tilt. So how on earth does a tilt cause seasons? Well, as the Earth travels around the sun, that tilt doesn't wobble around. It stays pointed at the same spot in the distant cosmos. This means for one part of the year, the top half of the Earth, the northern hemisphere, is tilted towards the sun. And for the other part of the year, it's tilted away. Let's take a quick trip through the year to see exactly how this works. Let's start around June 21st. Here, the northern hemisphere is literally leaning into the sun. The sun's rays are hitting us more directly, like a flashlight shining straight down instead of at an angle. That concentrated energy means warmer weather and longer days. This is the summer solstice, the official start of summer up north. Fast forward about 3 months to September. Now the Earth is in a position where the tilt is sideways to the sun. Neither the north nor the south is tilted towards it. The sun is shining directly over the equator. This is the autumnal equinox. Equi means equal and nox means night. Equal night. It's the point of perfect balance, where day and night are nearly the same length everywhere. And then we keep going to around December 22nd, and it's the complete opposite of what we saw back in June. Now, the northern hemisphere is tilted away from the sun. The sunlight hits us at a really shallow angle, spreading that energy out over a much wider area. The result? Colder weather and shorter days. Hello, winter solstice. You see how this works? It's like this incredible, predictable cosmic clockwork. These key moments, the solstices and equinoxes, they dictate the length of our days and the feel of our seasons with amazing precision year after year. And this chart just lays out the difference so clearly. Think of it this way. Solstices are about the extremes. They mark the longest day or the shortest day of the year. Equinoxes are all about balance, when the sun is directly over the equator, giving us nearly equal day and night. Extremes versus balance, that's the key. Okay, now this is where you can really see the power of that tilt. Just look at the insane numbers for the North Pole. On the summer solstice, it gets 24 hours of nonstop daylight. But 6 months later, it gets 0, total darkness for months. And then look at the equator. It's Mr. Consistent, just cruising along with 12 hours of daylight pretty much all year round. This chart isn't just data, it's proof of how dramatically that 23.5-degree tilt shapes our world. All right, this all leads to a question that I'm sure has popped into your head at some point. If we are spinning and flying through space at these incredible speeds, why does it feel like we're perfectly still? I mean, think about these speeds for a second. At the equator, we're spinning at over 1,600 kilometers an hour. And at the same time, our whole planet is hurtling around the sun at 100,000 kilometers an hour. That is ridiculously fast. So why aren't we all just flung off into the cosmos? Well, there are two big reasons. First, of course, is gravity. It's like a giant invisible anchor holding us and everything else down. But the really clever part is Newton's first law of motion. Basically, everything, you, me, the chair you're sitting in, the air you're breathing, is all moving at the same constant speed. It's exactly like being on an airplane cruising at a steady 800 kilometers an hour. You can get up, walk around, sip your drink. You don't feel the speed. Because you, the plane, and everything inside are all moving together as one unit. Our planet's motion is so incredibly smooth and constant that we just don't notice it. So there you have it. Our planet's daily spin and yearly journey create the fundamental rhythm of our lives. But Earth isn't the only one doing this cosmic dance. Imagine what seasons are like on Mars, which has a similar tilt to ours. Or what about Uranus, which is knocked over completely on its side, basically rolling around the sun? What would a day or a season even feel like there? It just goes to show, our cosmic dance is just one of many out there. And that's a pretty cool thought.